Rule number 7 is probably the most important rule in the entire Rules of the Road book for mariners, for deck watch officers, surface warfare officers, anybody operating a vessel. It's the risk of collision rule, right? And it's not particularly long. It's something you should obviously read. But in essence, it says that risk of collision exists when the bearing to an approaching vessel does not appreciably change. As an example of that, if you were standing in one spot on your vessel looking out into the horizon and you did not move around on the vessel, you just kept looking, and your vessel was proceeding at the same course and speed, if you saw a vessel out there on the horizon and it started moving, a little bit from right to left for you, or it started drifting back in the horizon and you started passing it, no risk of collision exists there. But if you see a vessel that is at the same bearing, from you to this boat is the same bearing, and all it's doing is getting closer and closer and closer, then that, in essence, determines a risk of collision situation. It's called bearing drift. So as you look out on the horizon, if the ship appears to be moving one way or the other relative to you, there is likely not risk of collision. However, if that vessel is on a constant bearing, but getting closer to you or having a decreasing range, that's probably a risk of collision situation. It doesn't matter what the aspect of the vessel is. In other words, it doesn't matter whether you're looking at its stern, its bow, or its side. If the vessel is at the same bearing but getting closer to you, there's probably risk of collision, and there could be a collision in that case. So this might be a common situation you could consider yourself in out at sea. You're on vessel red and you see vessel blue out there on the horizon. Well, here's what we're talking about with compass bearings not appreciably changing. If these two vessels are on a converging course, then there is risk of collision, obviously, right? If you were to put yourself on vessel red and look out at the blue vessel, you're going to see it at a bearing of 045 degrees to the northeast. As the vessels get closer, you're still going to see it on a bearing of 045. As they get closer, still on a bearing of 045, right? So that constant bearing, but the decreasing range is bringing the vessels together. Now here's the same situation where this vessel here, vessel blue, is not moving. If you're on vessel red, you're going to see the bearing at 045, and then as you move forward, maybe vessel blue is fishing, now you see it at 070, now you see it at 090. So there is no risk of collision because there's bearing drift. In this case, if you were to put yourself on vessel red, you would see vessel blue appear to drift down your starboard side. So you have right bearing drift in that case. Conversely, if you were on vessel blue and you were looking at vessel red and your vessel was not moving, you would see the vessel cross your bow. It would also have right bearing drift in this case, because if you put yourself on vessel blue, you look at red, the bearing is going to be increasing as it goes by. Another key tool for risk of collision is the maneuvering board. The maneuvering board represents your radar with you in the center, and you can look out, if say you see a vessel out on the starboard bow, you can plot it over the course of time and see if its bearing is decreasing, if its bearing is increasing, if its range is decreasing, or if the bearing is constant, right? So your typical situation is going to have a vessel that's out here, if it is plotted over time and it appears to be drifting left, you have left bearing drift. If it was here and then 3 minutes later, 3 minutes later, 3 minutes later, you're going to have right bearing drift. The cases to watch out for is when it's at a constant bearing but getting closer and closer. That doesn't mean the vessel is pointed directly at you, right? You could just be on converging courses. It's all about vector addition. If you want to learn more about the maneuvering board and how it can aid your collision avoidance decisions, check out the series Fundamentals of the Maneuvering Board. It's a free course on my website. So as you read the rule, take a minute to do that. One of the key things that is in the rule is all available means. So vessels need to be able to use their vision, binoculars, radar, ECDIS, VHF radios, any other tool to assess the risk of collision. But the best way to do it is to stand in one spot on your bridge, on your vessel, keep your course and speed, and just simply look out at the other vessel. If the vessel appears to be drifting to the left, it's got left bearing drift. If it appears to be drifting to the right, it's got right bearing drift. If it has no bearing drift, if it's on a constant bearing but getting closer to you, it's called CBDR. constant bearing decreasing range, and there is risk of collision. Now the rules also say that sometimes if you're approaching a very large vessel or a vessel that's very close to you, there can be a little bit of bearing drift and still be risk of collision. But bearing drift is the most important element to risk of collision. The rules also talk about using radar equipment and using it properly. So you need to use radar plotting, radar scanning, any technique that's available to you, you have to use according to the rules for determining risk of collision. The other thing about this rule is that risk of collision is a gateway to many other rules. So for example, in section 2 of part B, we're going to be talking about head-on situations, crossing situations, overtaking situations, all of which risk of collision is the first element of. So for example, when two power-driven vessels are meeting so as to involve risk of collision, well, that's what we're talking about here, the risk of collision, right? In terms of the test, the Coast Guard test, there's only about 20 questions about risk of collision in the database. And they're most likely going to ask you about constant bearing decreasing range. And then they're also going to ask you about whether doubt exists. So if doubt exists as to whether risk of collision is occurring, then risk of collision is deemed to exist. If you have any doubt, it does exist. All right, so go ahead and pause the video and take that quiz, and we'll talk about it in a minute. Okay, so for the first question, both international and inland, when is risk of collision considered to exist? According to these answers, if a vessel has a steady bearing but a constant range, that's not risk of collision, right? Because the vessel is not getting any closer. If there is doubt that risk of collision exists, then risk of collision does exist. So that's the correct answer. Looking at choice C and D, if 4 vessels are nearby or if a special circumstance is nearby, it's kind of the same thing. The rules don't say anything about that. For the next question, both international and inland, which statement is true concerning risk of collision? The correct answer is B. Risk of collision may exist when the compass bearing of an approaching vessel is changing appreciably. You may say to yourself, I thought it needed to be constant. The key word in choice B is may exist. May exist. So go back to the rule if you're unclear here and read it where it says that a particularly large vessel or a close vessel, there may be compass bearing change even though risk of collision still exists. If you look at the other answers, A, the stand-on vessel must keep out of the way. We haven't quite covered that in this course yet, but the stand-on vessel is the one that keeps going. And then choices C and D, risk of collision always exists when 2 vessels pass, not necessarily the case, or when the compass bearing of an approaching vessel changes, right? So if it has bearing drift, if it's drifting from one side of the window to the other, there's generally not risk of collision. For the next question, both international and inland, in which situation would risk of collision definitely exist? So the correct answer in this case is choice D. A vessel is on your starboard quarter and the range is decreasing, but the bearing is constant. So CBDR, constant bearing decreasing range, risk of collision does exist. For the other answers, choice A and C talk about 22 degrees. That's something that we'll talk about for overtaking situations. They're just trying to trick you there. But in essence, A, B, and C all have either the range increasing or the bearing changing. So choice D is the only one that has a decreasing range and a constant bearing. Okay, for the next one, both international and inland, which statement is true concerning a vessel equipped with operational radar? Well, you have to use the radar to determine whether risk of collision exists. You need to use radar plotting, radar scanning, any techniques, including ARPA. So choice A is the correct answer. Choices B, C, and D all talk about other things. You know, if you have radar that excuses you from a lookout, that's not correct, even referring back to the previous Rule 5, which talks about lookouts. Radar equipment's only required to be used in restricted visibility. That's incorrect as well. It must be used to determine risk of collision. That doesn't mean it needs to be used at all times. It needs to be used to aid collision avoidance. Finally, both international and inland, when do the rules state that risk of collision shall be deemed to exist? If the bearing of an approaching vessel does not appreciably change. So that's the language that's used in the rules. And it's always a good thing if you can memorize the rules and see the exact same language, it's probably going to be the correct answer. Choices B, C, and D are not correct for various reasons. 2 vessels approaching from opposite directions, 1 vessel is overtaking. No, it has to be when the compass bearing of an approaching vessel does not appreciably change.